So looking at these two functions, f and g, what is the domain of the f? The f is a square root function, and we cannot have negatives inside the square root, so the smallest that x could be is -2. And x must be greater than or equal to that -2 value. The range is going to be y is greater than or equal to 0, because we know that that value could be 0, and it's going to go up from there. For this function here, the domain and range of this, the domain of this is going to be x is all real numbers, and the range is going to be y is going to be greater than or equal to the vertex value, which is -4. Okay, the vertex is going to be at 0, -4. So what is this graph this combined function going to look like? It's going to be square root of x plus 2 divided by the quadratic function in the denominator. Okay, so what's the domain of this function? Well, the domain of this function is going to be based on the x cannot be less than -2, and we also have restrictions. So x must be greater than or equal to -2. But we also have restrictions that x cannot equal plus -2. So we're going to have to get rid of that. Combining these together, the restriction ends up being x must be greater than 2, can't be equal to -2, okay, because we have the restriction there, and x cannot be equal to +2. Okay, so putting this together, we can't really simplify this algebraically. This is something that we've not seen before, so how do we analyze something like this? Well, what's happening at plus minus -2? Well, those do not cancel, so those are vertical asymptotes. So I'm going to end up with vertical asymptotes at -2 and +2. And we know that x cannot be less than -2, so we know that this section in here, all this is restricted. We can't use any of this part. Anything to the left of this line is a no-go. Okay, we can't use any of that. So what's happening when we look at this? Well, I don't have any zeros. Okay, the numerator is not equal to 0 at any point except at -2. And there's an asymptote going on there. So I'm going to need to maybe use a table of values to figure out what's going on. I do know that those lines are asymptotes. And I should also maybe observe that as x gets really big, so I'm going to write this as a limit, as x goes to infinity, f of x over g of x, since the denominator is more powerful than the numerator, this is going to tend to 0. So I can expect the graph to kind of tend towards that line. So I have asymptotes are going to go towards that line. I'm going to make a table of values here just so that I have some coordinates to work with. So maybe I'm going to choose -1. When x is -1, I end up with, that's going to be √2 over -3. Okay, so that's going to be a negative value somewhere about 0.5. Okay, somewhere in there. Okay, so then maybe at x is 0, I'm going to get √2 over 4, -4. Okay, so that's going to be, looks like it's a little bit higher up there. It's hard to tell. Okay, so it's going to be somewhere in here. And at x equals 1, I end up with √3 over -3. And so it's going to be kind of going down, maybe somewhere around here. So it looks like I'm going to follow the asymptote like this. It's going to go up. It looks like it's going to come back down and follow the asymptote here. Okay, I'm just going to zoom in a bit and draw this a little bit better. Okay, so in fact I'm going to change colors. Okay, so the graph is going to follow the asymptote, kind of go through those coordinates and follow the asymptote this way. Now we can kind of expect the graph to kind of follow the asymptotes like this. We're going to confirm this by just plugging in a few more points. So at x equals 3, when I plug in x equals 3, maybe I'll choose some nice coordinates. At x equals 3, let's choose x equals, not 3, but x equals, let's choose x equals 7. At x equals 7, we get square root of 9, which is going to be 3. Over the denominator is going to be 45. Okay, so at x equals 7, it's going to be getting close to 0. Okay, so it's going to follow the asymptote and come down close to 0 like that. Okay, so the graph's going to look something like this. Now, this is going to be hard to do because we don't know, we've never really seen graphs that look like this, but what we do know is that the graph's going to follow the asymptotes. There's going to be a restriction on the left side here, and we can plot a few points to help us analyze this. Okay, so I plotted a few points here and followed the asymptotes, and this is what I came up with on the graph. And when I take a look at all my Desmos, it's going to be fairly similar to this. Okay, now you may not get that accurate, but as long as you understand, start interpreting some of these features, this is the idea of what we want to do.